Okay, we're going to do a quick overview of the DESI plan view section of the website. So let's start up here in the top left. This is your domain selector, so you can change it wherever you would like. So you just kind of drag and drop it and press the submit button. It's also really powerful because you can change the width and the height of the domain. So let's do 100 by 100. And you can see that domain size is 10% of the original size. This is particularly useful. Let's say you're at a fire or an EOC and you had limited bandwidth. And when you essentially make this domain smaller, this 10% of the size, you're getting 10% of the data. And so it will really speed up DESI if you are limited on bandwidth. But let's go ahead and set it back to what it was. So with DESI, you can do this web Mercator projection, or you can do a spherical projection. So you just press this 2D, 3D button. You can see now I'm in a spherical projection and all the data will be reprojected. Very useful for higher latitudes like Alaska. But I'm going to switch it over back to this web Mercator for us in this demonstration. All right, with DESI, it has the usual forward and backwards with controls. I can do it with my keyboard, which I'm doing now, or I can press the buttons, either or. This play button will animate DESI, and it actually interpolates between time steps, and that's why you get this smooth animation. Press the plus button to speed up the animation. The minus button will slow it down for you. Okay, so moving now on to maps. So these are the simple maps, or at least that's what we call them. You can do dark or light, but you'll probably gravitate towards these map box maps. So just go ahead and click it. Oh, it's not working in this particular example. So in the future, you can click it and change these map box maps. I have it locked for this particular case. Anyways, you'll also see under maps that you can add and subtract state lines, coastlines, etc. So that's kind of a basic overview of DESI and those controls. Let's go to our data set. So here you can change between the LREF, the HREF, and the NBM QMD data. I'm going to keep it right now on the HREF. And then you can select your member. So the Grand Ensemble is really just an aggregate of the 10 members you see below. So let's say you just wanted to look at the her, you can click on the her, the data will update, and now we're looking at the her. But for this demonstration, let's just look at the Grand Ensemble. So we're looking at temperature here. You can look at a mean temperature, so this is an average of all 10 members. You can look at the minimum temperature, the maximum, or all the percentiles, whatever you'd like. So oftentimes when I used to forecast, I would like to look at the range of uncertainty in the forecast. And so that would be basically, maybe looking at the 90th percentile. And let's zoom in on a certain area. I'm just going to pick Chicago because it's easy. So the 90th percentile shows it's going to be 60 degrees at Chicago. The 10th percentile, 48. So there's actually a big range in temperatures there. So you can do that all in your head, or under DESI, under this menu option, you can click this ranges button. So let's go ahead and click it. And that's going to compute the statistics we just did in our head. It's actually computing the 75th minus 25th, but if you click this little widget button over here, and that will do the 90th minus the 10th, there you get the 12-degree difference. So these darker colors represent a bigger difference between the 90th and the 10th, and certainly more uncertainty there. Okay, so just to show you the statistics button, we already went through that. That's the max, min, and the percentiles. The range button, we just did that. That shows you the difference between percentiles. And now let's go on to the timing button. So let's actually, I'm going to show maybe reflectivity. And let me find a case. No, let's jump back to temperature. So we can see the temperatures in this particular area are in the 40s. And as we go through time, they kind of drop into the 30s, but then warm up into the 50s. So with this timing button is you can find the time of any particular variable and when it happens. So let's say we're going to go to temperature and timing. Let's say we care about when the temperature is going to get above 50 degrees. I would go ahead and set my threshold to 50 degrees. My operator is going to be greater than, because I care about when temperatures get warmer than 50 degrees. And this type button, the onset, that tells me, or that basically means that I'm asking when will the temperatures get above 50, the first occurrence. And then the cessation would mean when would they stop going above 50. So I'm going to press this submit button, and you can see that about 15 hours from now, the temperatures will go above 50. Okay, and when will they not be above 50? This is the cessation. So 44 hours from now, they will actually go below 50 again. So just a nice way to identify the timing of particular variables. Again, it's probably more useful on things like reflectivity, or the timing of snowfall, or the timing of strong winds. And let's just see if we can find a reflectivity example in this particular case. So I'm going to go around the country. All right, here we got some reflectivity. And we can see a band of rain or snow moving into Salt Lake City. And if I went into my accumulated snowfall and I press the statistics button, I would see, okay, this is falling mostly as rain. So under this total precipitation button, let's say someone called and you wanted to know when is the precipitation, whoops. Let me fix that. Okay, going back to Salt Lake City. Oh man. Accumulated snowfall. Oh, we're going back to precipitation. Okay, so let's say someone called and they want to know when the rain is going to start at a particular area. So what I would do, I would go to the total precipitation and I'd press the timing button, and that will go through all the members and find the mean time when the precipitation will actually start falling. So in Salt Lake City, it looks like 45 hours from the initialization time is when the rain will start falling. That's the mean time. The earliest the rain would start falling is about 40 hours from now, and the latest would be about 47 hours from now. And you can press the percentage button to see how many members actually reach our threshold. Our threshold is defined down here as 0.01 inches. And I can see about 70% of the members reach our threshold and are computed in this timing statistics. So I can go ahead and press this all button, and that would show us all the timing information. So here's the earliest, the second earliest, the mean, the second latest, the latest, all being shown side by side. So it's a nice way to view that information. We can also do paintballs on DESI and on the plan view chart. So I'm going to go ahead and press that button. And this is basically custom paintballs. So you can see the threshold right here is 40 dBz, but let's lower it to 30 dBz. So this is obviously a synoptically forced event. You would probably want to use paintballs on convective weather, but you kind of get the point here. They're custom. You can change the threshold to whatever you like. And these paintballs are also available on a few other variables like wind gust and visibility. And if there's paintballs missing from a certain variable that you would like to see, just let us know. All right, last but not least, let's look at the postage stamps. So I'm going to go ahead and press that button. And what that's going to do is going to get the reflectivity from all the different members for our particular time period. And so there you have it. You got postage stamps of reflectivity for your particular location. All right, next let's explore the different data sets. So I have selected QMD data Alaska. So this is MBM QMD data, the quantile mapped interesting data from 4.1. And just like you could with any other data set, you can go up here and see the variables that we have. So we only have 2 variables listed here right now, but you can still do the same timing, statistics, ranges, and probabilities on these data. So if you wanted to see the min precipitation from the 100 members of the QMD data, you can certainly do that too. And if you wanted to see timing of precipitation, I realize there's not much precipitation going on right now. You can press that timing button and you would get an answer of when the precipitation would start at a particular location. And again, remember, we can press the percentage and see how many members are actually showing precipitation in that case. So that's the QMD data. There's not much there, but more will be coming. So last but not least, let's jump over to the LREF data. So this domain is quite big. You can go pretty much anywhere you'd want on the globe with this data. You can go up to almost the North Pole, you can go down to Hawaii, and of course you can go over to the CONUS. And that's where I'm going to be showing you data. Really the last thing that I wanted to show you on this plan view data is you can cluster on the LREF data. So let me just undo that. We were grouped by ensemble. And if you're looking at a different data set like the href, those group by buttons are not there because you can't group by cluster on this href data, but on the LREF data you can. So these buttons appear. And I'm going to go ahead and group by cluster again. What it did is just it did the principal components analysis on the 500 millibar heights of the grand ensemble. The grand ensemble in this particular LREF case is the GEFs, the Canadian and the European. And you can see it made 3 clusters for us. Cluster 1 has higher heights over California, and the shaded area represents the difference between that cluster and the grand ensemble. So the red means higher heights, and the contours are the actual 500 millibar heights. Cluster 2, you have lower heights over California, and cluster 3, just overall lower heights on the west coast. So I'm going to go to, or actually, yeah, just kind of hover over the California area. And, you know, we could look at the different clusters by selecting the different members. So here's cluster 1, cluster 2. But it's kind of hard to look at the differences that way. So we actually have this 4-panel button, or this, it will actually break the grand ensemble out into its components. So we got cluster 1 on the top left, cluster 2 on the top right, cluster 3 on the bottom left, and the grand ensemble on the bottom right. If you're like me, it's kind of hard to tell a difference between these clusters. So that's why we have this A minus B button. And what that A minus B button did, it essentially it takes the difference between that cluster and the grand ensemble. So you can see cluster 1 is warmer over California, which is denoted by this orange shading. Cluster 2 is a little bit cooler over California, and that kind of makes sense because you see these lower heights in cluster 2. And cluster 3, which has the lower heights over the Pacific Northwest, is colder than the grand ensemble too. So we're focused on day 7 here, but you can pick any day you would like. So that's a quick overview of DESI and the plan view section.